Add a whole number to a decimal in most languages, and it quietly converts one of them for you. Go does not. It stops and refuses to build. That feels strict the first time it happens, but it means an entire family of surprising bugs simply cannot occur in Go code. In this lesson, how to ask for a conversion, and 3 traps that catch people even once they know the syntax. Here is code that looks completely harmless. Count is 3. Go sees a whole number and makes it an int. Price is 4.5. Go sees a decimal and makes it a float 64. Then we multiply them together, and Go stops dead. Invalid operation, mismatched types, int and float 64. And notice what Go is not doing. It is not picking one for you. It could widen the int to a float. It could truncate the float to an int. Both are defensible, and they give completely different answers. So rather than guess, Go makes you say which one you meant. Converting looks like calling a function, except the function is the name of a type. On the left, the broken version. Count is an int sitting next to a float 64. On the right, we wrap it. Float 64, open bracket, count, close bracket. Now both sides of the multiplication are float 64s, and Go is perfectly happy. 3 times 4.5 is 13.5. The same shape works for any conversion. Int of something, float 64 of something. The type name goes on the outside. And notice this does not change count itself. It produces a new float 64 value from it. Count is still an int on the next line. First trap. Turning a float into an int throws the fractional part away. It does not round it. 3.9 becomes 3, not 4. The 0.9 is simply discarded. And minus 3.9 becomes minus 3, not minus 4. It truncates towards 0, so it moves up rather than down for negative numbers. If you actually want rounding, that has to be a deliberate step. Add 0.5 before converting, or use math.round. The conversion on its own will never round for you. There is a related detail worth knowing. We are converting variables here, on purpose. If you write int of 3.9 directly with the literal number, that is a compile error. Constant 3.9 truncated to integer. The compiler will not silently drop the 0.9 from something you typed out yourself. Truncation only happens to a value that is already a float when the program runs. Second trap, and this one is not really about conversions at all. It just bites people constantly. Divide 2 whole numbers and you get a whole number back. 7 divided by 2 is 3, and the remainder is thrown away. That is not Go being odd, it is integer division, and it is the same in C, in Java, in Rust. The fix is to convert first. Float 64 of 7 divided by 2 gives you 3.5, because now one side is a float and the other follows. But look at the third line very carefully, because this is the one that catches people. Float 64 wrapped around the whole division. 7 divided by 2 happens first entirely in whole numbers, giving 3. And then we convert the 3. So it prints 3. We converted a 3 into a float, long after the 0.5 had already been thrown away. The rule is short. Convert before you divide, not after. Third trap, and it is the one that produces the most confusing output of the 3. You have the number 65, and you want the text 65, so you reach for string of 65, because that is what conversion looks like. You get a capital A. Because Go did not read that as, turn this number into its digits. It read it as, this number is a Unicode code point, give me that character. And character number 65 is capital A. That is why we have written rune 65 here explicitly. A rune is a Unicode character, and spelling it out makes the intent obvious. This is a genuinely useful operation when you actually want a character. It is just almost never what a beginner meant. So how do you actually turn 65 into the text 65? There are two ways, and you will use both. The first is the star-conv package. ITOA stands for integer to ASCII, which is an old name from C, but it means integer to string. And we can prove we really got text, because adding the string to itself gives us 6565, joined end to end, not added up to 130. The second way is sprintf, which you already know from the printing video. %d, one value, and you get the string back. Rule of thumb: star-conv when you are just converting one number. Sprintf when you are building a bigger string with other text around it. We will come back to stconv properly in the standard library module, including what happens when the text is not a valid number. It is worth stepping back for a second, because this is a real design decision and not just fussiness. Go refuses to guess which type you meant. Every conversion in a Go program is visible. You can see it, right there in the code, and so can whoever reads it next. The cost is a few extra characters. What you get back is that the silent, drifting precision bugs of implicit conversion never happen to you. That is a trade most people come to appreciate about a month in. 4 things to take away. Conversion is the type name wrapped around the value, float 64 of count, int of price. Converting a float to an int truncates toward 0. It never rounds. Convert before you divide, not after, or the whole number division has already happened. And string of a number gives you a character, not digits. For text, use trtondmv.itoa or sprintfolief. Those 4 cover, essentially, every conversion mistake there is. Your turn. And this one puts 2 of the traps together. You have a total of 7 and 2 people, both whole numbers. Work out what each person pays as a float 64 and print it to 2 decimals. Each person pays 3.50. Watch the division trap, pause, and try it. Here is the answer. We convert both numbers to float 64 before dividing, so the division itself is float division and gives us 3.5. Then %.2f prints it as 3.50. Converting just one of them would also have worked, because once one side is a float, the other follows. But converting both says what you mean, and it is impossible to misread. What would not have worked is dividing first. Float 64 of 7 divided by 2 would have given you 3.0 and a quietly wrong bill. That closes out types. Go will not mix them for you. The conversion syntax is always the type name wrapped around the value, and the traps are truncation, division order, and strings. Learn those 3 and type errors stop being annoying and start being useful. Next module: making decisions and repeating work. If, for, switch, and defer. Go's control flow, which has fewer pieces than you are expecting.